This week, I'm going to be talking about URI resolution in Deephaven, go into a little bit of some lower level details that I don't think we've gone over before, and then jump into custom resolvers, which I think is where the most interesting part of this stuff eventually will lie. Let me present a screen now. When I say URI, this is a kind of like a URL. It's not actually a URL, but it's a uniform resource indicator, I believe. And it's composed of a couple different parts, typically a scheme, an authority, which is a username, a host, and a port, optional, an optional path, and then an optional query, and then an optional fragment. You'll probably recognize all these different parts, just implicitly from clicking on a bunch of links in the past. But it's not just for resolving websites. We have defined our own URI scheme in Deephaven to resolve Deephaven table resources and potentially other resources in the future.
So how does authentication work with the URIs?
There are sometimes you can pass in like a password here too. So you'll do username, password. It can sometimes look like that. In some cases, I believe once we hook up Deephaven authentication is probably not going to be part of the URI. It's probably going to be controlled when you're setting up your session in some other way. So I don't think it plays into part right now necessarily. It might in the future, but we aren't hooking into user info at all right now. So you've seen a little bit about this before. So typically what you do when you want to grab something from the local scope is you just say, your left-hand side equals your right-hand side. I've started up a application already on application startup, and I've got a couple tables that are already created. And so typically you just do, a variable assignment statement. So if we run this right here, we go ahead and grab the scope variable current time and put it into current time _ traditional. So that's how you typically do it. And you can see it's ticking every second here with the current time. We have a way to do the same thing via URI resolution. And so we can execute this resolve with this format. So it's the Deephaven scheme. There's no host. And then we're saying we want to grab the scope variable, and then the name is current time. So if we can go ahead and run this, we'll get hopefully exactly the same results, and we can see them are both the same here. Both ticking there. There we go, ticking together. So they're the same thing. Go ahead and exit out those. You might ask, well, why do we need scopes or URIs to resolve locally scoped stuff? You don't really need it. But what this does is it sets you up for a structure that you can use later in other contexts. And we'll see that shortly. You can do the same thing with application fields. So an application field isn't something you can just do a left-hand side equals right-hand side unless you go through resolution. So here is kind of the same idea. Here's our URI format for application fields. We've got our Deephaven scheme, no host, application name, field name. So I've set up an application with the ID time-application, and I should be able to go ahead and resolve this here to the current time. Not too exciting, but it does give us some ability to be a bit more descriptive with how we structure things that we want to present to users.
And so for the application here, does this have to be a certain type of application, or is this URI going to look the same if you do a script versus a whatever?
So this will, if you set anything into an application field, this will be the way to do it. An application can also set scope variables. So it's actually the time application was also responsible for creating this current time on startup. But if you are properly setting stuff into an application field, it'll always look something like this. But that's a good point. If it doesn't matter whether it's a Python application that's creating this or a Groovy application that's creating this, the URI looks the same in either case. Now, the scripts that we can run right now are only Groovy because that's what I'm running right here, but you could do equally the same thing in Python. So where it becomes interesting is now we can use the same scheme that we've seen before, but in a remote context. So I've got a couple of extra workers that I've spun up called W2, W3, and W4. This is just in my Docker Compose. I've basically copied the gRPC API logic and have just started a couple more servers. And this is showing like we can grab, look, the start time. This was another variable that the application defined, and current time, and we can grab it from each of these other workers. And so it looks very familiar to the URI that we saw earlier, where there's a scope and then a variable name. In this case, there's a little bit more. The scheme's slightly different in this case because we are connecting to a remote host over plain text just to keep things simple. And then here's our host name, W2, W3, and W4. I'm just presenting it in a slightly different way, merging them all together so you can see them side by side.
So on the host side, can you specify plain text versus whatever to constrain it?
Sure. So if we had a secure connection here locally, we'd be able to change this to Deephaven : and use TLS. We don't have that set up right now, and so we're just when we connect remotely right now, we're going to be using Deephaven plus plain, and we can see here are when our different applications started up. It looks like W3 came up 2 seconds earlier than the rest of them. And we've got some ticking times here. Because the LTMs aren't necessarily in sync across these different workers, the times that we see here are slightly different, but you see they are ticking once every second. So this was something we couldn't easily do before, but now we're able to use the same scheme that we can use locally, just tack in a host here, and now we're able to get that table via a Barrage subscribed table. And of course, we could do the same thing, but with the application fields. So we could grab them via, app time application, the name, then field name. It's basically going to be the same output as we had before, but in different contexts, you might have your table in an application field instead. And just like before, we've got stuff that's ticking here, and W3 started up, 2 seconds earlier than the rest of them.
So is there a way to query these endpoints?
Not right now. There will potentially in the future be something called service discovery, where you can try to learn more about what's available to you locally. Potentially resolving the host automatically based on the application name. That's future work for us to do, but there's nothing like that exists right now. And that's a good idea. Potentially you could have something just spitballing. You could have like let's be completely theoretical here because this doesn't exist at all. Do Deephaven DH plus discover or something like that. I mean, you don't give it a host name, but based on this context, it knows it has to search for time application and fill in the proper host here for you. This doesn't exist today, but theoretically it could exist in the future. Let's move on. Let's close these tabs. So under the covers, This URI resolution is doing stuff via a Barrage subscription. And so we can expose some of that Barrage resolver stuff to potentially do more powerful things. So I guess I think some of you have seen this before. I've actually got an external server running in the Google Compute environment. So it's not on my local host. And there is a table that it's exposing called quotes. And I can apply a filter to it after the fact. So let's just try to grab these quotes for Bitcoin right here. Let's hide this column. Just drag the bid and ask over here so you can see it's changing, I hope. Can't tell. Looks like the timestamps are relatively recent. But anyways, what we can do is we can drop down to a more specific interface called the Barrage Table Resolver, and we can do more complex things. So right now the URI resolver is relatively simple in what it's letting us do. Like we can grab a plain text and then we can filter it locally, but we can't filter it remotely. That doesn't exist right now. So what we can do is we can get the resolver and we can formulate the same sort of logic, but filtered remotely instead. So we can do it's a subscribe instead of resolve. Resolve is kind of the generic term. Once we have a Barrage resolver, we're a bit more specific with our terminology. In this context, it's a subscribe. We give it the host we want to connect to, which looks like the beginning of our URI up here. And then we can give it a table specification for what we want it to do. In this case, we wanted to get the quotes from the query scope, and we want to filter it. And the reason why it's different than this one is, again, this is filtered locally, and this is filtered remotely. So we should be able to do this right here. Oops, I need to do my import or grab my resolver first. I can run this. And here we go. So here we've got our table ticking here, and it's filtered remotely. So we don't have to pull down any data that we don't care about, which is nice. So at the end of the day, URIs aren't trying to be everything. They're not trying to do our full complex table logic. Really, it's meant for grabbing things that are already predefined, maybe having some extensions here and there that do more interesting things. But right now, if you want to do more interesting, complex Barrage subscriptions, you can drop down to the Barrage resolver. You can specify the host, and then you can give any sort of table that you want right here. Like, we could do where, and then we could just do, if we only wanted to get the very first thing that matched, right? We could go ahead and run that there. And again, this is all happening remotely. So if we just wanted to filter and then grab the first thing that we saw, so there's our one row. And we don't have a format that says, like head equals 1 and, where instrument equals USD. We can't do this. I don't think we necessarily want to do this. This is introducing a lot of things that are less expressive than we can do with our clear language. So if you want to do more complex things with Barrage tables, you can drop down to the resolver and do whatever you want here in still a pretty easy fashion.
Can you comment on ticket table here?
Yeah, so ticket table is how we expose the server objects as arrow compatible output. So Deephaven heavily uses and extends the Arrow Flight protocol. And as part of that protocol, there's an idea of a ticket. When you want to get something from a server, you need a ticket for it. And so this is basically a binary format that the application or the server and client need to agree upon. And so we have got a specific binary format that we agree upon for query scope fields. If I wanted to do, if I was going to do an application field, I believe it's from application field, and then it has two things: application ID and field name. But in this case, ticket table is how we refer at a binary level to objects. So if we had a Arrow client that didn't know anything about Deephaven, we'd be able to use the same logic, and we'd be able to give them some binary bytes, and they'd be able to resolve the quotes table. Under the scenes, I believe it is just S quotes. And so if you took this string as literal bytes, then that would be what the actual ticket is in this case. And then, of course, because we've got our table interface behind it, we can follow that up with more complex things like a filter and then some more logic, and we could even join stuff in here if we wanted to, and then subscribe to it. The other thing some of you might be interested in is resolving Parquet data locally. So we can define a Parquet format here, or Parquet URI, that is basically just has no host and then grabs this file. Of course, you could go use Parquet tools. And again, URIs aren't trying to be everything. We don't have all the configuration options that Parquet tool has. But if you've got a simple use case and it's shareable with a single string, we can go ahead and resolve it using a URI. This is, I believe, 10,000 rows here of just some data. And you can also, let's say we wanted to get the same URI, but we wanted to do it from a different host. We can format it as a proxy. And so we can say, okay, host W2, I'm going to send this to you. Can you resolve this locally and send it back to me? In this case, it doesn't look very pretty because we had to URL encode this URI, but we can go ahead and run this, and hopefully we should get this back. So this is actually a Barrage subscription to worker 2 who has loaded up this URI in its instance right there. This is all pretty experimental right now. And I'm thinking that there are ways to improve it to make it a little bit cleaner. And so I've made this comment right here. I think I want to change the format to look like this. I think it would be a little bit nicer if instead of using a Parquet scheme up front, we use Parquet in the path. And then to refer to it remotely, it looks exactly the same. You just add in your host right there. I think that's a little bit clearer than having to encode it right here, but that's something we might see in the future. And then what I am personally most excited about is what I'm going to call custom resolvers. And that's where we can use our URI resolver infrastructure to allow third-party developers or use cases or whatever it may be to define their own URI schemes that they want to have resolved. So I have added some custom logic in my own namespace here. I'm just calling it foo bar logic under the package dev and rsmith. so what I can do is I can go ahead and run this, and it doesn't really matter what it's doing right here. It takes in two lists of integers, does a cross join on them, and then adds them together and then multiplies them together. So you can see here's our output right here. If we wanted to do, 1, 2, let's say 42, and we could cross join these and add them and multiply them together. So there we go. This is some custom code that I wrote. And we might want to have a URI format around that. And so that's what I have right here. I've defined it as the Deephaven scheme, no host, and the path Devon with query parameters foo and bar. And so I can execute this right here. And we'll jump into the server side code here in a second so you can see a little bit of the infrastructure that is needed to support this. I could change this. And really what we're doing is we are taking a string URI format and we are deserializing it into some sort of custom logic code call. And you might say, well, why would we ever want to use a URI when we can just import foobar logic and call it directly with stronger types or whatever we might have? And it really comes down to, I think, what it enables in the future. In the future, we'll be able to potentially resolve via a remote website right here. Devon.com or something like that. I might want to host this service on my website, and I want people to be able to call into it and have it parameterized like this. And they don't have this code locally at all. This code is just on Devon.com server or something like that. So the end user can't call this, and so what this would represent is a Barrage subscription to Devon.com, and then foobar logic running on that server that resolves this just as it did here locally. And so that's something I think to look forward to in the future, and why I'm pretty excited about custom URIs. And it kind of gives us the ability to have parameterized queries in a URI fashion with simple strings that we can share with people. So I can, I could go ahead, if this was actually a thing, I could copy and paste it. I could give it to Pete, or I can give it to Chip, and I could say, hey guys, go check this out, and they'd be able to run it on themselves without actually needing, the foobar logic package or anything like that. So let's actually jump over to the server just so you can see what it took for me to create this. I'm gonna go ahead and stop sharing the screen.
Do we have these URIs supported in all of our client languages yet, or is it just partial?
Not yet. This is obviously we're resolving it right now via the console session.
Right.
The Java client has full support for URIs, or it will very soon. There are some security concerns when you're dealing with generic logic, and we need to make sure we have a good, let's say, a systems administrator approach to it, I think. So there's some configuration and in some safe by default things that I think we need to go through before we really before we really enable some of this stuff remotely. But that is in the works right now. And once that is in, it should be really relatively straightforward for the Python client and any other client to pick it up. So I've got a very simple class here. Has one method, foobar, and this is what we saw the custom code was. It takes in a collection of integers, foo group and bar group, does a cross join of them, does an addition, does a multiplication. It's all doing it in the QST, not that it has to. and then it's resolving it down to a DB table, returning a DB table. So the exact logic here doesn't matter so much as the glue that puts the pieces together. And so that is what I'm calling the Deven resolver in this case. And you can see I've got basically just two classes here to define this logic. And what the Deven resolver does is it says, here are the schemes I support. Here's the path I expect. Here's the query pattern I expect. And then the interface around this, the Deephaven server basically expects custom code to implement this interface right here. What schemes do you support? Is this specific URI resolvable via your custom code? And then finally, resolve the URI or resolve it safely. The difference between resolve and resolve safely is if you're coming from the console and you've already got full access to the server, you can resolve without necessarily worrying about safety checks. If you're coming via the API, we got to invoke it via resolve safely and check any configuration to make sure it's safe. So in the case of Deven resolver here, here are the schemes we support, DH and DH plane. The URI format, I'm saying there can't be a host. We've got to have a path that equals /Deven. We've got to have a query pattern that matches foo bar, and we can't have any user information or fragments. So I'm just trying to be as specific as possible about what we accept here. And then when we resolve it, we basically take the URI, we grab we decode our query, and you don't have to use regex here, but you could resolve the URI in whatever ways you want and get data out however you wanted. In this case, it was pretty easy via regex. I'm splitting up those groups into integers, and then passing it off to our custom foo bar logic. And so really what all this setup is it's so we can take a string, so we can take a URI, and we can deserialize it, and we can call, a strongly typed code path somewhere, in this case, foo bar. And this could be, a ticking table. This could be backed by a Kafka stream. This could be whatever we wanted here. And this URI resolver would encapsulate it in whatever way it wanted to encapsulate it. And then one final part of the puzzle to get it automatically picked up is we can drop this file into the resource. It's a service loader mechanism in Java where it can automatically detect things that implement the URI resolver's interface. So we just drop this file here, and we say use the Deven resolver right here. And then when the server starts up, actually we should be able to go to the terminal here.
So would multiple resolvers be listed just sequentially in the file?
Well, the Deephaven specific resolvers aren't resolved or aren't picked up this way. They are explicit. If we look at
right, but I can imagine a case where you have an application that has multiple.
For sure. So what we can do here is we could let's just create a new resolver here. Okay, let's just call it Deven resolver 2, and we'll just call it Deven 2. And we'll just switch the order in which foo and bar is called here. Actually, let's give this a better name. Let's just call this my name backwards, right? That's going to be that resolver. And so we've got slightly different logic here. It should match ours, and it's just calling these backwards. What we could do is, we could just go ahead and go just do a different one here. We could list that here. We could grep the server logs for the resolvers that it found when it started up. In this case, it found this resolver during startup. We should be able to do a we should be able to go ahead and compile here, and we should be able to get this resolver up and running, and it should be picked up because it was added to here, and we'll see if it works or not. Always fun to try stuff live here. Terminal, okay. So let me go. Restart the gRPC API. And I am going to jump back to the other screen now, as long as it comes up healthily. There we go. Looks like my server is up. Is everybody able to see this?
Yes.
So this is the same thing we had before. We can go ahead and run this resolver. We actually don't care about this logic anymore. Let's only worry about the resolved code. So let's do it backwards now. So let's do, this is going to be bar foo. And it's the same format, but it's or slightly different format. So let's go ahead and resolve this and see if it actually picked it up. Hey, look there, it worked. We've got our arguments backwards now. So, and I'm assuming if we go and see the logs, it'll say it picked up this resolver right here. So that's kind of how you can expose custom logic via a URI scheme. And again, it's not necessarily the most interesting case locally, because look, we can call foo bar logic locally here. Where it becomes more interesting is once we can start saying remote host 1 and remote host 2, and this is it allows the application developer to present any custom logic that they want to their users in some sort of parameterized fashion, without having them have a local script session or something like that. So. And I think that's about all I had for URIs. Of course, I think some of you have seen earlier, we can also resolve CSVs via URIs. I don't have any pre-canned examples for that. In the future, we may consider having Kafka resolvable via URI. The one reason why that might be a little trickier is because there's a lot more configuration options that you need to set up Kafka to a Kafka stream. So that I haven't even attempted that yet. I'm not sure if it makes sense or not. But hopefully, we'll find that as we develop out example applications and stuff like that, we'll find uses for presenting custom logic for whatever application you want. Like where I'm interested in it at is if we go back to our what did I call it? Our resolver. What I think would be cool is instead of having something like this where we can resolve this, I think it would be cool if somebody wanted to have their own crypto prices API. They'd be able to do something like, prices, and they'd be able to go, ticker equals BTC, in that or something like that. So that's where my imagination goes with custom URIs is you can define something that makes sense for your domain and you can lightly parameterize it in ways that make sense for the application you're trying to expose. Again, this doesn't exist today, but the building blocks for building something like this out does exist.
So how much of this do we have documented?
The server side code is relatively well documented. The reason we've got some developer oriented documentation around the scope format, the local scope format, the local application format, the remote scope, and the remote application format. These are all pretty well defined. The Barrage stuff is pretty well defined. With the server side documentation that we have, there's a lot of documentation around what a resolver is and what's expected of it. So this is the URI resolver interface. If we go to there is some, let's see. I mean, it's not much right now, and maybe we need to better express it. But this kind of shows you can install URI resolvers based on Service Loader for third-party extensions, and that's how we picked up the Devon resolver, and the other resolver right here is via the Service Loader mechanism, and that's that file that we had to add right here. And so anybody could drop a jar on the class path if it had a resolver in it, and it had this file, the Service Loader file in it, we'd pick it up on server startup. And then the ones that we bind explicitly are the query scope resolver, the application resolver, the Barrage table resolver, the CSV table, and the Parquet table resolvers. But yeah, that's what we've got right now.
Okay, so is this something we should suggest people use, or is it still moving around enough where we just sit on it?
I think once we've got it via the API, then I think it makes sense to start talking about it. I think if there's anybody that's interested in application mode, they'd probably be interested in potentially having custom resolvers as well. Anybody who is interested in interacting or pulling down data via Barrage, I think is going to be interested in potentially custom URIs. So I think it's just around the corner. But hopefully by I'd say the end of month release would be a good time to say, hey, if you can see here, I've basically got three class files and a service file. We could potentially wrap it up in Python too to make it accessible to Python developers, but it is a very small core set of things that are necessary to add custom resolution. So I'm
Yeah, so I think my last question is just a security question, which seems to be one of the things in flux. So for the server, will it be possible to say that clients can only connect through whatever secure mechanism A?
Yep. So that's a good question. We are still talking about exactly how we want to plumb through security. From the enterprise context, we've got a lot of experience with ACLs in multiple user situations. We may end up exposing similar constructs here, or we may get to a state where we are working more on a single user security model. I'm not sure, but I think at the end of the day, we're going to try and leave both doors open for both types of users or end users. Like if you want to run a completely open system locally easily, or if you have a remote system that only one user needs to access securely, like we should be able to support those cases. If we are talking about a multi-tenant, multi-user situation, I assume we're going to want to support that too. The exact configuration for those different situations is probably going to look a lot different just because of different levels of concern. At a very minimum, there are flags to turn off different methods of resolution. And actually, I've got Parquet resolution resolver and the Barrage resolver turned off by default. So one change I had to make was to the startup. In the startup logic, I have to specifically enable the Parquet table resolver. And I specifically have to enable the Barrage table resolver. And so that is kind of the first layer of security that we might want to present users with, is just turning the whole resolver off or on via something like this. And then when we get into it, though, there's going to be a lot of cases where it's up to the individual resolver to define its own security context. So, for example, the Parquet table resolver, we might want to say you can only resolve. Let me go to it. So we go down to this configuration and we ask, is this URI enabled? So you can see I've got a to-do here, some sort of format that allows for allow or deny lists. So, what we might want to say here is they can open up data, my Parquet star. They can open up, let's say data Parquet star, or they can open up, anything that ends with .parquet, right? Like that might be a set of ACLs that we want to enable as a general basis. Somebody else might want to say, I want to namespace this. So I've got different groups in my organization and I want to have different levels. Like let's say I've got, data and I've got a trading group here. And so I want, traders allow, and, otherwise, deny or something like that. So when we talk about ACLs and security, there's a lot of different potential ways to configure it. And I think the conversation is still open on exactly how we're going to best enable, external parties to make the best decisions for themselves. What I'm really pushing for is a blanket way to completely disable a resolver just at a high level. And then probably some safe defaults that says, you can access anything under data star, or you can access anything that ends with .parquet, otherwise deny. And then provide extensions for people who have, or organizations who have more complex security needs, and they've got user groups and they've got groups with users in them to be able to specify, should they be able to resolve this path. It's a bit simplistic when we're talking about Parquet files because it's limited to the file system, but like when we're talking about a generic resolver here, when we want to resolve safely, there's any sort of custom logic can be put here, and for the custom resolvers, it's kind of going to be up to the third party to define how they want to safely handle it for whatever use cases they have.
So my question is, I got this feeling that this could be the Deephaven's way of allow users to develop some kind of services, right? For a broader market.
Yep.
But I know it actually depends on Barrage. So any generic gRPC client might not be able to consume it. What do you think about that? Can we maybe dumb it down, say okay, if this client is not Barrage enabled, maybe we can
Yeah, for sure.
do something.
It is going to be completely easy, I think, to have a do get, I think is what you're getting at. So not a full subscription, but I imagine
Right.
that we should be able to allow, Aero flight native clients to do a do
Right.
get
Okay.
against a URI. And that seems like a relatively easy thing to enable. Yeah, it's a good question. It's at the end of the day, it's going to be creating a ticket format. I think we talked about tickets a little bit earlier when we were talking about scope tickets. You know, um, 2 bytes. So this is kind of the ticket, the arrow ticket, the arrow flight ticket for a scope table called my table, and it's bytes. So we can define a ticket format for URIs, and it might be in the future that the ticket format actually just becomes the same as the URI format. But what we might say, ticket is going to be right. Like, this is a completely reasonable thing for us to want to do. And we might just say that the URI format becomes the ticket format, in which case you can do, like your do get on this exact bytes right here. And then you don't need to worry about Barrage at all. I could see a different situation where we want to be a little bit more generic. And so maybe we prefix it U/, then the URI comes after that, and that's the ticket format for URIs. I'm not sure, but that's in this case. Actually, you're probably not going to have a host because you already know what host you're talking to, so it's probably going to look, if you want to talk about connecting to a server and then getting a URI from it, maybe it looks like that or something. So this is completely theoretical, but something that should be easy to do if we find the need to be able to do that. Of course, you can today do it without a do get as long as you create the export first. So you can create an export for this is getting a little bit down in the weeds. But what you could do, I think I actually have get URI table, an example here. Could do a do get on it. I might actually be doing that here. I think I'm actually doing that here. So do gets already work, but you have to export it to the server first. You can't get it natively just yet, but it's a good question.